Hi everyone. Firstly, I hope you're well. I hope you're safe wherever you are joining us from around the world. My name is James Rasell. You may know me as J Rasell, and I am an engineer on the Nomad ecosystem team for HashiCorp. And I'm here today to talk to you about the Nomad Autoscaler. This is a new project from the Nomad team. And so who is the Nomad ecosystem team? We currently consist of 4 engineers, Louise, Chris, Jasmine, and myself. And we are tasked with building and supporting Nomad integrations. And so what are these Nomad integrations? So they are integrations that aren't vital to running Nomad itself, but they enhance. So once you have your Nomad cluster running, maybe you have a few jobs, some of the things that we're building will enhance your cluster and make it easier for you to run and maybe more secure. But including these integrations, we do some work within Nomad core. And so because of that reason, we work quite closely with the core team. We review, we design, and we rubber duck with them very closely. One of the kind of cool benefits of working on integrations is that we test these points quite heavily, the API and such. And so we can sometimes find interesting bugs. That's maybe in my case because I don't read the docs properly. And so I send some requests that maybe are full of garbage or something like that. So that's quite helpful. And for those of you who are not maybe familiar with Nomad, what exactly is it? It's quite a complex topic, what Nomad tries to solve, but we package it and expose it simply. It can run on multi-cloud, it can run on-prem, and there we have a sense of multi-region, multi-data center, federated clusters. No matter what your internal team topology looks like, we can support a very, very wide variety of workloads. We have first-class support for Docker, Windows, Java, VMs, so we have everything. Even in the community, there are some great plugins, there's some great drivers, such as Podman, FreeBSD jails, and even a great new Windows driver. And we have native integrations with much of the other HashiCorp tools. So we have this Lego box style approach. Take what you need at the time and then build. And so before you start a new project, we always need to look at why. Why do you need this new tool in this plethora of tools that you already have? And so why Autoscale? And so I've put these in kind of how I believe an operator or manager might look at the importance. We have respond to demand, all right? As your product becomes more popular, you're going to want to ensure that you meet the requests. You shouldn't penalize users and you shouldn't do any harm to any bad work that increases traffic. As well, if you have service level agreements, you want to make sure they're met. You might be able to scale manually, so you might know some of your traffic, you might not. So responding to unpredictable load is very important. Even if you try to scale to predictable load, it's going to cause stress on your operators, your human beings that work there. Manual changes are often time consuming, they're often error prone. And this can often make the changes worse than if you had done nothing. And so finally, we've got reduce the waste. So this is something that I've definitely dealt with before, and I'm sure a lot of you have as well. As your product becomes more popular, or your application, maybe you add new features, maybe you add some new team members that help identify new features, data scientists, quality assurance. And so your running costs can increase quickly, and they can increase quite silently in cloud environments. And once you get to that point, when your manager comes across your desk and says, we need to get this under control, it takes a fair amount of work. So cost focus is an important part of business maturity. And especially in today's current climate, it's very, very important to focus and make sure it's under control. So now we've got the why. How? So there are 4 types of autoscaling. Horizontal scaling is the most common. We have lots of prior art. We have things like Amazon's autoscaling groups, Azure scale sets, and Google Cloud Instance sets. I think I got that right. And in traditional environments, this might be a one-to-one mapping. So we might have one instance of your application per server that you have. And so as you scale that out or scale that in, you have a direct correlation. In a Nomad environment or any containerized environment, that starts to become differentiated and different. Application scaling horizontal is where we take more instances of your application and raise that, or we lower that based on the demand. And so what are you scaling those task groups on, in this case for Nomad? Well, that's going to be some form of server, right? And so if you keep scaling your application indefinitely, you might reach a point where you have no way to go. You can't scale anymore. There's no more CPU left. So this is where horizontal cluster scaling comes in play. And it's literally the idea of adding servers or removing them from your schedulable resource pool. And then we get on to vertical autoscaling. This is a lot less common, but it's becoming a lot more in vogue as a topic. And it has a lot more underlying complexity than horizontal autoscaling. When you run your application, it's very hard to understand what resources you need to run. You might pick some sensible defaults based on a little bit of testing, and you might actually use these defaults across different types of application because they use the same underlying language. They're also fixed for the full application lifecycle. So if your application needs a lot of memory when it starts, but then has a small memory footprint once that's finished, there's nothing you can do. The same goes for server sizing. You'll probably base this based on basic requirements and some estimated costs. But that's about it. And it's very hard once you have this in place that you're going to change it. It might stay that way for 1, for 2 years. And trying to change it is very time consuming. And so this is where I'm going to introduce the Nomad Autoscaler. It's an official HashiCorp Autoscaler for Nomad. The current focus is on horizontal application autoscaling. So the first one of those 4 boxes. We're currently working hard to develop and design this. And we're taking a lot of some of the lessons that have been learned from existing autoscaling offerings, both from the community and for more enterprise offerings that are used in the cloud. So what did we change as part of this initial release? Previously, community-driven autoscalers have integrated in several different ways. Policies were in job parameters. Maybe policies were stored in states in the scaler. And to scale, you had to read, modify, and then register the whole job back to Nomad. So it was mildly insecure as well. You also had no way of knowing scaling events had happened unless the autoscaler had telemetry or state. And so one of the things we did was a new job specification stanza which could handle scaling policies. Excellent. And as part of this, we introduced new endpoints. So we have endpoints for reading policies, and we have endpoints for scaling and also seeing scaling events. This also makes it easier to build your own. If you have a particular special requirement, then hopefully these endpoints reduce the amount of pain to integrate with Nomad. And then the Nomad Autoscaler itself. So this is a brand new project. We have our own release cadence. It's separate to Nomad binary. There are some version requirements as we develop the Nomad API, as we make changes. We keep a version matrix in the README for that. But with the nightly builds particularly, because we're iterating so fast and trying to add new features, if you see a feature that was added a couple of days ago or even a day ago, you can use the nightly build to test that out. We want to get feedback quick. We want to get feedback early on what we're building. We also deploy it as a binary or a Docker image, a binary for multiple different OS architectures. So our preference is to run the Nomad Autoscaler on Nomad itself. Nomad can manage it. But if you have a reason why that is not appropriate, you can take one of these binaries and run it in however manner is applicable to your use case. It's inherently difficult for us to support every use case that there might exist. So for this reason, we've architected the Autoscaler around plugins, very distinct areas, and we'll discuss that in a minute. We use the pretty widely used Go plugin package. This is used throughout HashiCorp in some of the major products. And so we want to make it so that we can include as many use cases as possible. We also make as the most efficient use of Nomad as we can. We don't want an external tool to impact Nomad. At the very least, it might slow down deployments, might slow down requests. At the very worst, it could cause the cluster to crash, and it might impact all your running applications. So we use blocking queries, internal caching to make sure this doesn't happen. This has been kind of one of the larger pieces of work that we've actually focused on to migrate some of this, and is always still a focus of what we're working on when we're designing. And so how does the Autoscaler work? Like, how can you as an operator, as a developer, as a sysadmin, control it? So if we ignore all the config components that are used to configure the agent and the parsing and stuff like that, we have two main components. We have the policy handling and evaluation and the plugin management system. And that's pretty much it. And if we take a look at the evaluation flow, it's what we have here. It's a closed loop control system. So if you're familiar with these, or if you're not, it's similar to when you regulate the pressure of a tank in an industrial plant to keep your car going at the same speed via cruise control, or even most commonly, keeping the temperature in your house constant with a thermostat, right? So the input we have is the policy. In the case of the Nomad Autoscaler, think of a thermostat, that would be your desired temperature. What temperature you want to keep it, no matter what the conditions are outside. Then we have the controller, the yellow box. That is the Nomad Autoscaler core, or the controller. And then the purple, we have the target. So in the thermostat, this might be a radiator or it might be an air conditioning unit. In the Nomad Autoscaler, particularly for the horizontal application scaling, this is the Nomad cluster and the Nomad task group count. And even the target keeps feeding back information. So what's the status? Give us some metrics so we can continually compare the current state to the desired state. And so how do we configure this? So this is a scaling policy. This is one that you could take. You can put this in one of your jobs right now and it will go and scale. We're explicitly configuring some fields just to give you a full view of what it might look like. And now we'll go through every section, try and explain a little bit so you understand more. So the top section, so we've got these three values, enabled, min, and max. Enabled lets you administratively disable or enable this scaling policy. Say if your application is having problems, say if you just don't want the autoscaler to interact with it for a bit while you make a few changes or decide something, you can set this to false and the autoscaler will skip this evaluation, giving you better control and we won't interfere with it. The minimum and maximum are always adhered to by the autoscaler. So if the autoscaler takes this policy, decides, hey, I want to scale to a max of 21, the autoscaler will actually look at that and say, no, you can't do that. We're going to lower that value to 20. This just stops a situation where maybe you have a bad metric, maybe there's something that's misconfigured, misfiring. We just don't run and scale forever and cause more problems than there is. This part is the only part that's validated by Nomad itself. So if you want to build your own autoscaler, you have a policy that you believe is more fit for your purpose, then this is the only section you really have to adhere to. Everything else, you can make it up how you wish. Then we get into the policy section. So the cooldown and the evaluation interval. So these both take time durations. That's pretty common in Nomad. The cooldown defaults to 5 minutes. That is a fairly standard unit for cooldown across most of the cloud providers and most of the autoscalers. The requirement for cooldown, what do you need it for? So when your application is starting because of scaling, you want your load balancer to start distributing traffic. You want your metrics to catch up with what's going on. And so this just prevents thrashing. It prevents scaling too rapidly and not kind of letting the system settle. Thrashing can cause high load on your Nomad servers. Thrashing can cause pretty bad instability in your applications. Then we have the evaluation interval. This is defaulted to 10 seconds. And this controls how often the Nomad Autoscaler will evaluate your policy, how often it will evaluate the current state to the desired state. And so these two values in combination with each other really control the overall policy and how it works. If you have low values for this, 1 second, you're going to get very rapid actions. They're going to change very often. It's going to be probably quite dangerous. If you have higher values, you're going to have more conservative scaling, slow, maybe steady, but maybe you'll miss out on some traffic because you won't be reacting to it quickly enough. Then we have the APM section. So this is where we define what APM we would like to talk to, and we define the query that we're going to talk and gather back. In this sense, I don't think it's an actual proper formed query. That would be too long, but here, for example, we're looking for the number of concurrent sessions to our instances of our application. There is a current requirement that the query must return a single value. We have discussed internally loosening this and allowing an array. the reason we're very reluctant to do this is that APMs such as Prometheus, such as Datadog, they're much better at performing these types of queries, right? They're built to do this. They're much more efficient. We don't want the autoscaler to turn into its own APM, which then brings a whole new set of problems. And so the target section, this target defaults to Nomad, the Nomad target, and so you can omit this if you want to do your application autoscaling. But it's there for fulfillment, to make it look good. And so the target plugin, as I mentioned in the control loop, has two responsibilities. It alters the number of running instances of your application, but it also supplies status information. So how many are there actually running? When was the last actual scaling event? This is so we can capture things like out-of-band changes. So say if you have a rogue program that is running and accidentally scaling when it shouldn't be, the autoscaler can actually look at that and omit scaling for that turn. We don't want to impact what's going on externally. And then we move to the strategy. The strategy is kind of the brains. It's where the maths happens. And what we've got here, we have the target value. So a target value aims to keep the specified, the supplied metric at the correct value that you put in that configuration block there. So if we take this example, where we're looking at the number of connections that we have open to our application, if we have 2 instances running and we have, say, 15 current sessions returned, the autoscaler, the strategy, would recommend moving to 3 instances. This would take us from between 7 and 8 current sessions per instance to 5, which is what our target is. And if we take a holistic view at things, this is what it looks like. We have a single strategy, a single target plugin, and then we have 2 APMs. Why is this? Well, Nomad is quite inefficient for this. Every time we do a lookup, we have to make 1 plus n calls, where n is the number of allocations you're running. And as I said, we don't want to turn the autoscaler into an APM. And this is a visual representation of where those config parameters in that policy fit in this plugin ecosystem. And you can see they're pretty well divided up. This is so that if you change your value, you know exactly what part of the system it's going to impact. So say you change what the cooldown is, you know that's going to be handled by Nomad Autoscaler core, and you know where to look. But there's only really so much slides can teach us. For me personally, seeing, doing is much better, helps me understand the topic. And so we're going to look at this demo, and what does the demo have in it? Well, so it aims to try and run through some real world scenarios. And it probably fundamentally follows what you might experience when you're thinking about introducing an autoscaler to your environment. What happens when we don't have autoscaling? How do you want to kind of introduce autoscaling using this dry run flag? Autoscaling then, the third point, is kind of what might it look like when you have it, when you've tested, when you're deployed properly. And the final one is just going to be very brief, but we touch on scaling to 0 for real flexibility. The demo isn't kind of geared to that, but I want to introduce the topic. You'll see we're using Prometheus for all of the metrics rather than Nomad. So Nomad can only supply CPU and memory. These are quite fickle to try and get consistent scaling from. And so this is why we're using Prometheus. And so in true demo style, what is actually the worst that could happen? Probably quite a lot of things, but we're going to go and take that risk anyway. And so we're going to get right into this. So I'm using Shipyard to build all my infrastructure pieces locally. Nice, simple, based on containers. Should take less than a minute to start. What is it deploying? So we're deploying Nomad and Console. We are using a Unicorn Rails app to simulate Nginx, a cache, a database. So it's just not static responses, a single static page. And all services are using Console Connect. Why is that? Well, we get some very interesting metrics from the Envoy sidecar, which we can use to scale. And also because Console Connect is pretty cool, right? And so this just takes a moment to start, brings up all our containers. And so once that's done, we'll have everything locally. We've got Nomad, we've got Console, and we've got a really good application with some great metrics loaded for us. And it will just take a moment. A bit slower than I remember. And there we go. And so now with that running, you can see that we load up Nomads. you can see that we have a Nomad server in our HashiCorp digital region in our Valencian data center. And we can go over and just take a little look at the Nomad UI, see what's starting. And you can see we've got all our jobs. Apart from Grafana, that's usually the slowest, the more lethargic one to start. But we've got our monitoring, database, Nginx, and our Unicorn application. And so now we can go over to Grafana, or actually no, we can go over to the service UI, and we can actually see how our service looks. You can see the path that a request will take. You can even see the duration of the request and the response code that we actually got back. And now we can go and have a look at our Grafana dashboard. Grafana's a bit annoying, so I have to find it this way. And here we go. So we've got some interesting tiles up. We've got the memory usage. We've got the number of running instances and the average requests per instance. Now this is going to be the metric, the thing we're looking at. We can also see the total requests. We can also see the response code. So obviously we want 200 response codes. But what are we going to actually get when this starts running? And so once we've got that, we're going to run over. And so you'll see that we have no scaling policies running. So this job will not scale. The Unicorn app cannot scale. Nomad doesn't know anything about it. And so we're going to start some loads. We're using Hey to simulate some customer load here. It's not too much. We're running it for 5 minutes with a concurrency of 2. But this will soon quickly overwhelm your application. On the left, you can see quite quickly, number of instances start coming up. The number of requests start increasing. To the start, we get 200s, but it doesn't take long for us to start getting 500 responses back. That's not good for your customers, right? So looking at the graph, you've got about 50% 200, 50% 500. So 50% of your requests are failing to your application. And that's just going to keep increasing, and it's probably going to stay pretty consistent. And so the average requests keep going up. It doesn't get any better. We don't have anything on our app to self-heal, to improve the situation. And if we cancel Hey, we have a look, 50-50. That's not the best, right? And so what can we do to improve that? Well, we can run an autoscaler, right? We have an autoscaler and we can start testing out how autoscaling might improve our environment, how it might improve our customer feedback. And so what we're going to do is we're going to run an autoscaler. As I said earlier, we're going to run it as a job on our Nomad cluster. And the configuration is quite minimal for this. If we take a look in the file, you can see that we're setting up our Nomad client to point to the right address with the right region. We are going to instantiate a Prometheus client so that we get some good metrics and we know where to gather our data from. We're also loading a strategy, which is our target value plugin, the only one, unfortunately, we have available for us at the moment. And then a couple of different parameters. So the cooldown, just so that I can show that you can change that and how it works. And also our bind address. So what's our bind address used for? So, excuse me. The Nomad Autoscaler exposes a health check. At the moment, this is just an aliveness check. We have tickets to improve it. And you can see that we get a 200 OK back. So you can at least have some confidence the autoscaler is up, the autoscaler is running. And so that can be used as a console health check, for example, in your job, just to provide added security for you. And so with that running, we're going to move on and we're going to check the autoscaler is there and have a look at the logs. So this is a nice way to do it through Nomad. We need to look at the standard error and have a look at the agent logs. And so you'll see that we've launched all the plugins that we were expecting, all 4 of them, all the defaults, and we have started our blocking query for efficiency on the policies. And then we also have the open health server so that you can query, make sure it's okay. And so then we're going to trigger a new job. We're going to trigger a new allocation of our Unicorn application, right? We want to make sure that we're going to be able to scale this properly. think I took some time to write this piece. And so we're going to deploy this. And so this job is configured with a dry run. It can be quite scary, right, to deploy an autoscaling application straight away. So we have a thing called dry run. Dry run lets you deploy a scaling policy for autoscaling and let it be evaluated without actually changing the ultimate count of your application. And so this is the scaling policy of the job we've just deployed. You can see that we've got the min, the max, the enabled values. You can see our policies. So we're using this rather grotesque query, but this is effectively asking Prometheus, what are the average number of connections open to our unicorn instances? And gives us a single value. So say, okay, currently you have 10 open connections per instance of your application. And that's what we want to look at. Further down, you can see that we've got the strategy. We're looking for 6 connections per instance. That's going to be our target value. And then we have our target. So we're using the Nomad target, but we have critically this dry run flag. So this is where the autoscaler will check this and it won't actually make changes to your underlying application. And so we can have a look, see what's going on with our unicorn application. You'll see that we've got a new allocation. That's great. That's expected to happen. We've registered a new job. And now we're going to add some load to it using Hey again, just to get some customer data running through. And so now we've got to wait for a couple of minutes just to get Prometheus updated. But we're probably not going to change much from the response codes, right? So we're not actually scaling the job. This is just dry run. So we're probably still going to fail. But if we look at the Nomad logs, you'll see that, okay, the autoscaler actually looks at the load, looks at the metric, and did want to scale up because of this factor of 1.5. And it wanted to scale up to 2. And as you'll see, the dry run is true. This means the autoscaler is not going to submit that change, but it's there. And so if you have a look at the unicorn status again, you'll see that nothing has changed. We haven't made any changes to your system. We're just informing you what might happen. So this gives you a really nice feel to understand what's going to happen. Okay, maybe you want to play around with metrics, play around with the counts, just fine tune before you actually let anything loose into your cluster which might impact your customers or at least impact one of your environments. And so once you've done that, you might want to remove that flag. And we're going to deploy this new job exactly the same, just it has the dry run removed from it. You don't have to remove it altogether. You can just say it's a false and it will still go. And we have this cooldown of 1 minute, kind of sensible. Maybe you'll want more, maybe you want less. For the purpose of the demo, works beautifully. So that's what we're going to go. Just a reminder, so the default is 5 minutes. Might be a little bit long in this, but that's perfect for other reasons. So we're going to go, we'll submit that job to our cluster, which will not give us a new allocation. All we've done is change a flag of the scaling policy. That doesn't need us to re-register to update the job in a destructive way. It will give us a new version, as you can see. And so with all of that done, we now have a job that is capable of scaling with some decent defaults, and we have an autoscaler that can actually do that. So now what we're going to do is we'll start incrementally increasing traffic into our application. This is more like what you might actually experience in your environment. You may get blasts if you haven't fine-tuned. We're going to do this. It's going to work hopefully very well. And so we start with some load here. And what are we doing? How's it going? So we started making requests, and if we head over to the Grafana UI, again, a bit slow, but already you can start to see the number of requests per instance increasing up. Very helpful. And you'll see that we're getting 200s. That's great. Okay, that's what we want. But as this load increases from what we've seen, you might struggle. But because we now have the dry run removed, the Nomad Autoscaler will actually enact change. And so you can see that we have desired a count of 3 because of the load that we have. And that you will see there is no dry run. And if we take a look at the green line, which is the number of running allocations of our job, you can see that that starts to increase, right? So that's moved up to 3. So the Autoscaler has submitted that job and we've scaled. And conversely, the number of requests per instance, the number of active connections, has dropped down to what is an acceptable figure. And we haven't had any 500s. So we've managed to take that load, we've managed to make it work and not perform any bad requests for our customers. So let's go ahead and add some more load into that, to that application. You've added a new feature, you've added maybe some new cat gifts to your application, so that's going to be pretty popular, right? And so what does the Autoscaler want to do? So quite quickly, it's come out of cooldown, it's looked at the metric and it's decided, okay, we need more instances of this application to handle this load. And so we've moved up to 5, we've requested 5 instances, and again, put ourselves into a cooldown of 1 minute, just so that these new allocations have a time to start up, the Nginx has time to distribute traffic, and then we can let the metrics settle down and then reevaluate. And if you have a look at the Grafana, you can see that's exactly what's happening. We're kind of chainsawing these lines together. We have more instances coming online, and the requests per instance are lowering. The allocations are handling the traffic. And importantly, we're still not getting any 500s. And so for the final bit, let's just split this up. And we can add a final bit of load to our cluster, just to make sure that this isn't a fluke. We're not lying about this, right? And again, it might take a minute. We are in a minute's cooldown. So it'll take a couple of seconds for us to start doing anything here. But you'll see that just as I click here, we increase the number that we want to look at, right? And critically, you'll see here is that the Autoscaler has wanted to run 9 instances, but has dropped it down to 8 to make sure it doesn't violate the maximum parameter. And then told Nomad, okay, I want 8 allocations of this job. And if we go back to the dashboard, we'll still start seeing this again coalescing together. You'll see that we have now 8 allocations of our application, and we're hitting 6 requests per second, or 6 requests per allocation, which is exactly what we wanted from our target. And you'll see that if we go along this graph, there are no 500s. So we've incrementally increased our load, as what you might happen with your website. And we haven't dropped any custom requests on the floor. We haven't returned any 500s. It's ideal for what you want. And so we will take off the load now. We don't need this anymore. We see a couple of 500s there. Not sure where the difference comes from here. I'm not sure if this is, hey, maybe talking to Nginx when one of the backends is just wrong. The Nginx has no configuration, so there's probably some tuning to be done there. And that's great. So that's kind of what you might deploy to your prod environment, right? And so now we have no load. You'll see that the Autoscaler will gradually start to rein things in. We don't need 8 allocations of that application running. So we'll start to gradually reduce that number as the load is dissipating away. And so this gives us this nice curve that we have, which might be if you're running an e-commerce site, when's your most popular times? Maybe in the morning, at lunchtime, and in the evening when people have more time. And so we get these peaks and troughs, which is what you want. And so here we can see our requests have dropped down to nothing, and we start to reduce the number of allocations we have running. And so this will continue for a few moments. As it just keeps dropping down, we should come out of our cooldown here in a moment. And you can see 31 milliseconds how accurate to go. And hopefully the Autoscaler should take some action here. And there we go. So the Autoscaler actually wanted to go to 0. Because of our minimum threshold, it will change that to 1 to make sure that it doesn't violate that. And then it submitted that to Nomad. So now we should have 1 allocation running of our application left. And from the Autoscaler's standpoint and from your metric standpoint, that is enough to fulfill all the traffic you have coming into your application. And so that's what you might have in your prod environment. And so the final bit of the demo, as I said, isn't really fit for this piece, but I want to show it off. There is a great talk done 2 to 3 weeks ago by Eric on cloud bursting using Nomad and Nomad Autoscaler. If you're interested in more about deploying to 0, I'd highly recommend it. But scaling to 0 is quite useful if you have maybe an app consuming from a queue. Or if you have physical hardware and then you get an influx of requests, it's very hard to rack up a server, bring it online very quickly. And so this really helps those situations. And so we're going to run this job that we have. All we've changed in this job policy and the scaling policy is that the minimum count is now 0, right? This job is allowed to scale to 0. That's fine. This is probably not ideal for if you're serving live requests. If you have a very good API or a proxy, then maybe you could get away with this. And so we're going to run that job. And so this will probably scale down to 0 quite quickly. We're not in cooldown, so the next iteration, that's going to happen. And immediately it happens, right? So there's the metrics, there's no metric, there's no data, we don't have any requests. And so we submit to 0. The UI is a bit misleading. The job isn't dead. I would class it more as in hibernation. But this is great. And so from the final bit, you can see from the Grafana dashboard that we have scaled to 0 requests. And if we look just across the final bit of the whole demo in total, you can see where we've come from. So we had no scaling. Then we tried scaling to see what would happen. And then we deployed it maybe to our production environment. And so you get this really nice increase in traffic. And you see that we managed to meet all of that. And that's perfect. And so that's the end of the demo. And the most important thing at the end of the demo, destroy everything. Make sure you don't have anything left behind. And so there we go. Perfect. And so that's enough of the present, right? What does the future of the Autoscaler look like? As a team, as a company, we have some features that are in progress. We also have some that are planned. But that's not to say that any feedback isn't really welcome. And it really may help shape the future of our development process. That being said, if you have a very particular use case, something that is very, very specific to you, the plugin architecture means that it's quite easy and straightforward to build a plugin for your use case if you so wish and you have the resources. And we're always happy to help guide, help advise, and just provide feedback from our point. And so scaling your application we demoed, that will get you so far, right? But what if your app becomes so popular that you run out of space on your cluster? And so this is where we introduce horizontal cluster autoscaling. We are targeting Amazon Web Services, ASGs first, generally because of the popularity in the community. And this will allow us to scale out and in our cluster based on your allocated resources or any kind of constraints you have, whether that be, I need more GPUs in my cluster. The work on this plugin and this feature will also drive a lot of the core maturity. We've tried to build the first iteration, the first releases, in a way that there aren't any assumptions that we're just doing horizontal application scaling, but that's not a guarantee. So this will help us smooth out any of that. Also, cluster scaling is a lot more complex. And so this will really drive some maturity in the core offering. Once we've got the initial AWS target done, which may take a bit of time to design and to implement, implementing other cloud providers should be a lot quicker. A lot of the heavy work will be done initially through AWS the design. And so we'll be initially targeting potentially Azure scale sets and Google Cloud Instance groups for additional cloud provider cluster autoscaling. As I said, and I probably keep mentioning, if you have any feedback, if you think another provider is going to be more beneficial, just tell us. We'll be happy to hear and we'll definitely take that on board. And so the plugin nature allows us to build fairly quickly new plugins, right? And we know that the catalog we have is slightly limited. One of the biggest time sinks in building a new plugin is learning that remote provider, understanding, okay, what call should we be making? What is the most efficient call to make? And so we're initially targeting potentially Datadog as an APM, a pig controller strategy, and even a scheduled strategy. So when I mean scheduled, I mean, say if you have an application that only is used during office hours, for say, the schedule can say, okay, scale my application from 0 to 5 at 8 a.m. in the morning, and then at 6 p.m. at night, take that application back down to 0. Save myself some money. So if we take a look back, this is the ecosystem that we have right now, right? It's minimal, it's useful, but it is limited to application scaling. So what might this look like in a few months, in a year, in a few weeks? So this is the kind of landscape we're driving towards. It has flexibility to meet hopefully most use cases. And even in the unique use cases, it provides an opportunity to accommodate with some simple interfaces. So if you have your own call strategy, that might be there. Whereas the picture focuses on the plugin ecosystem, this doesn't mean we're kind of neglecting the Nomad Autoscaler core. So we'll be working on efficiency, high availability, observability, so as an operator, what is actually happening here? And even just the core autoscaling feature set. Maybe there is an autoscaling feature that Azure uses that is quite a neat feature, and you want that within the Nomad Autoscaler. And we'll be looking at things like that as well. And so if you're interested in learning more, I will share these slides so that you don't have to try and divinate what the links are. If you're interested in learning more about Nomad or the Autoscaler, the first two links will take you to the home pages, so you can give them a go, understand a bit more. If you have any questions or feedback, please go ahead and use the Nomad Discuss forum. We're pretty active on there. We try to monitor it and respond as quickly as we can. If you're interested in learning about autoscaling just more as a subject, as an academic subject, the first paper gives a really good look at the current state of autoscaling in clouds. So it takes a look at the main providers, takes a look at their autoscaling offerings, and gives a really good dive down into what they were, how they work, and how they compare. The second link is a recent paper by Google, which discusses vertical application scaling. So one of the cool new in vogue topics, and particularly focuses on Autopilot, what they call Autopilot, which is their Borg vertical application scaler. Sorry, very interesting paper. So if you have some time, I'd recommend reading that. So I'd like to say thank you for watching. Thank you for taking the time to listen to me today. I would like to thank everyone that has helped me, provided feedback for my demo, for my slides. Also, everyone that's made this conference possible. It's a new challenge, and it's been great to be part of. If you have any questions or feedback, feel free to reach out at the Discuss forum, as I mentioned, or you'll be able to find me online with the Rasell handle. Enjoy the rest of your conference, and goodbye.